Hi everyone, Mr. Neighbor here, and we're continuing to talk about acceleration. So remember, acceleration is a change in the velocity over a change in time. And to calculate final velocity, we can use this formula if we want to break it down, but we can use this one using the initial velocity plus the average acceleration times time. So we already did this problem over here, so let's continue on with this one. A toy traveling at 50 centimeters per second slows down to 20 centimeters per second in 10 seconds. What is the toy's acceleration? So first, what are we looking for? Are we looking for final velocity? Are we looking for acceleration? Choose the formula that actually works for your problem most efficiently. So I would say, since we're trying to look for acceleration, we use the acceleration formula. So what is our change in velocity? It's going 50 and it drops down to 20. So that means it is actually a negative velocity. So it's 30 centimeters per second. Okay, so that came from subtracting 20 minus 50, because remember, it's the final minus the initial. All right, then we divide that by our time, which is 10 seconds. So when we do that, we will get out -3. And that would be a label of centimeters per second squared. All right, now let's look at sig figs really quick. We're subtracting two things that only have a significant figure placement to the 10th spot. So that means this number, sig figs, is to the 10th spot. So when I take 30, which only has one sig fig technically now because of that addition, divided by 10, which has 3 sig figs, take the least precise number, which is 1. So this is the correct answer right here. Notice we leave our answer as centimeters per second squared. That's perfectly fine. You could change it into meters per second squared. Look at your conversion chart. When you do that, it's simply a matter of dividing by 100. Or I could just write -3 times 10 to the -2 meters per second squared. Really easy when we use scientific notation. So either one of those works. All right, remember when we were talking about Aristotle and Galileo? Aristotle believed that the heavier an object was, the faster it would fall. Twice as heavy falls twice as fast. That's Aristotle. Galileo, on the other hand, believed that you need data to prove what you're talking about. So Galileo collected data concerning falling objects. And what he observed was the following: when those objects were dropped near the surface of the Earth. So at 0 seconds, they weren't moving. At 1 second, it was -10, 2 seconds, -20, 3, -30, 4, -40. So before you move on to what this question is asking, make sure you understand why this is negative. It's negative because in Galileo's terms, he considered up to be positive. So that's positive y. So objects are falling down, which means the direction is negative, meaning the velocity is negative. All right, so based on Galileo's data, what is the acceleration due to Earth's gravity of a falling object? So remember, acceleration is just a change in velocity over change in time if we're talking about average. So let's just look at one section. One interval of time. So from 1 to 2 seconds. So the final velocity -20, initial velocity -10. When I subtract those two, I should get out -10. Dividing that by a change in time, which is the final time minus the initial time, which will give me out 1. I have a label of meters per second in the numerator. I'll have a label of seconds in the denominator, meaning I have -10 divided by 1, which is -10 meters per second squared. So Galileo discovering that the acceleration due to gravity at Earth's surface is -10 meters per second squared. And really, our calculations don't say this. We're using these numbers here, but this is an approximation. The the acceleration due to gravity is not quite -10. It's a little under that, typically referred to as -9.81 meters per second squared. So when we talk about free fall, we're talking about objects falling near the surface of the Earth with negligible air friction, meaning you can neglect the air friction. You can forget about the air friction and not worry about it. At that point, objects will accelerate toward the Earth at an acceleration of negative 9.0 meters per second squared. So really, I should have had this be a 1 because rounding would make that a 1 if you looked at the actual value. So acceleration due to gravity, which we sometimes write as A sub g, is equal to negative 9.81 meters per second squared, which is equal to negative g. So if you ever see g, that means the number 9.81. We will use the number 10 instead. We use 10 because that's pretty close, and then we can actually use this number to calculate problems in our head easier, so we don't have to have this very specific value. Our problems that we're going to do in this class are not going to make or break the universe. It's not going to be some huge scientific discovery. We're not putting people on the moon where those little details matter. So 10 is completely fine for having an approximate answer to gravity. All right, so some practice. A rock is dropped off a high cliff. What is its velocity after 3 seconds have passed? So we're talking about a final velocity. So that's calculated by the initial plus acceleration times time. So our initial velocity, if it's dropped, is 0. The acceleration, it doesn't give it to us in the problem. But when we're in free fall, we're relying only on gravity. So we're going to write negative 10 meters per second squared. We're talking about for 3 seconds. So when I go ahead and calculate this, this is now an average amount because I'm approximating this velocity. So 10 times 3 is 30, so I have negative 30 meters per second. This will be 3 significant figures. The reason why it's not 1 with the 10 is because that 10, that's an approximated value. That's not a number that was actually given in the problem. You only use the numbers that are given in the problem when you do significant figures. Let's try another one. What is the velocity of a rock that is thrown downwards at 5 meters per second, 2 seconds after it's released? So we're looking for a velocity, so find a velocity. The initial velocity is thrown down at 5. So I will symbolize down as negative. So I should do an arrow and say negative y is down, or I could just do an arrow and say positive y is up. So somehow I know that that's what I'm stating for the problem. The acceleration due to gravity, since it is in free fall, is 10 meters per second squared. Notice it's negative because it is going down 2, and that's 2 seconds later. So when I do these calculations, I'll have negative 20 right here, plus negative 5, which is negative 25 meters per second. Looking at sig figs, I have only one sig fig here. It's actually going to give me out the number 20, which goes to the 10th place value. Here I'm only going to the 1's place value. So with those place values present, I have to go to the least precise one, which would be the 10th place value. So my answer will have to go to right here. So that will make my final answer negative 30 meters per second. Notice I have the negative there to show, hey, we're going downward still in our velocity at this time.